Good morning. My name is Don Megan. I'm a member of the Math Science Innovation Center staff. This is clean water. You can see the four visual observations that we're making is, first of all, is it clear? Can you see through it? Yes, it is. Is it colorless? Yes, it is. It doesn't have any color to it. Does it foam? No, it doesn't. Clean water is not supposed to foam. And lastly, are there any particulate matter in it? Is there any particulate matter? Are there particles floating in it? No, we like to call those crunchies. Water is not supposed to crunch. So there are no crunchies. It is clear, it is colorless, and it doesn't foam. That's clear water. That's clean water. I've made some water here that's not so clear. That's not so clean. As you can see, this water is not clear. It is cloudy. You can't see through it. It's not colorless. It has a green color to it. It foams. And it has crunchies. It has things floating around in it. All of these things make the water not clean. We're going to use a process to clean up the water. That process is a physical process called filtering. Now, the way a filter works is a filter is a material that has small holes in it. Those holes are big enough to let water and air pass through. But other materials, like dirt particles, for instance, are too big and they get caught. They get trapped on the filter. Pure water means it is completely safe. Clean water is only visual observations. Pure water involves two other kinds of processes. We need to have chemical processes that would remove harmful chemicals, things like mercury or lead or other things that we would consider to be poisons, pesticides. You have to be able to remove those from the water. They also have to be able to remove things from the water that cause the water to be too acid. You've heard of acid rain. Acid is not good. We need to be able to reduce the levels of acid in water. And then the third set of processes are biological processes. We have to have some way of reducing the amount of bacteriological contamination in the water. Make sure that the bacteria and the viruses are removed from the water. So those are the three kinds of processes that water treatment plants will do to make sure your water is clean. We're only going to be looking at the clean water, not the pure water. The materials that we're going to use for our filters are not paper. The first one is ordinary cotton balls. The second one is ordinary sand. The third one is ordinary dirt. And believe it or not, dirt is very good at cleaning up dirty water. So dirt can clean dirt out of dirty water. The next one is a material called perlite, and it is a crushed volcanic rock. And the last material is activated carbon. Cotton, sand, soil, perlite, and carbon. There's one material in each one of these, only one material, because I would like to see what effect each of these materials has on our dirty water. Because I want to then be able to design my own filter using a combination of these that would be better than any one of them individually. Okay, so I'm back now. I have filtered my dirty water through these filters now, and I'm going to show you what each one of them does. This is the cotton, so it's filtered into this. I'm going to put a cover on it so I can shake it, but I'll show you. It still looks green. It's not the same as it was before. This is what it looked like before. This is what it looks like now. You can see the green color is a little bit less here. Does it still foam? Yes, it does. Is it clear? No, it's still cloudy. Not as cloudy as it was, but it's still cloudy. Is it colorless? No, it's not. It still has some color in it. Does it have any particulate matter? No, it doesn't. All of the particulate matter is gone from it. So that's what cotton does. Here's sand. designs, putting something together with 2 or 3 or more different kinds of materials. Do you have to limit yourself to cotton, sand, soil, perlite? No, you can use anything you might think would make a good filtering material. You probably don't have tubes like this, but you know what you could use? If you take a water bottle, cut off the bottom and turn it upside down, now you can take a coffee filter, stretch it over the opening in it, hold it in place with a rubber band, and now you'll be able to fill it with material that you think might be good filtering materials. You can put them in any order that you want. I've put together my own filter design here. And if you look carefully, I'm going to take this out and hold it up closer so you can see what I've designed. I've designed it so it has cotton in the bottom third, it has carbon in the middle third, and I decided on sand in the upper third. So I've got 3 of these things together, and I want to see if they do better than any of them individually. Okay. Now, as scientists, we like to record what we do. So I have a little picture here that I put together where I have different patterns for my materials, and you can see I've sketched what I have here. So I have the bottom third is cotton, the middle third is this pattern that corresponds to carbon, and the top third is the pattern that corresponds to sand. This is so I can record it. So if I do a different one, I can make sure I record my observations here for each one that I do. So now I'm going to filter this. You'll be able to see how these things are filtered now. So I'm just going to pour it in slowly. I'm going to try to keep the material, keep the tube full without it overflowing. I don't want it to overflow. As the water seeps down through, it's going to take a little while. It takes a little while for this to happen, especially with the carbon in it. The carbon slows things down. But pretty soon you're going to see water come dripping out of the bottom. And that's our filtered water. Okay, I'm going to keep this as high as I can, because the bigger the column of water, the heavier the weight of that water, and the faster it will force the water to go through. So you probably can't see it from there, but the water level is down to about here. It's soaked to about there, and it's working its way down through the carbon layer. It's completely through the sand layer. It's working its way down through the carbon layer, and it will get into the cotton layers. Okay, so as you can see now, it is filtering. The water is working its way down through the sand layer, through the carbon layer, through the cotton layer, and it's dripping into here, and it's being collected in this container at the bottom. You can begin to see what it looks like down here. It doesn't have much color to it. All right? Does it have any particulate matter? No, there's nothing floating in it. Does it foam? Let's shake it and see if it foams. It still foams, so we still have some foaming that's taking place, but there's no particulate matter. So you can look at this and compare this now to each of the individual ones here. Would this have done something differently if I put the cotton at the top and the carbon at the bottom? I don't know. We'd have to do the experiment to find out. That's what one of the fun things about science is. You get to experiment and see what happens when you make a change. When you do this experiment yourself with a water bottle, I would suggest you draw a picture, draw a sketch out for what yours looks like, how much of each are there, what the layers are, and then dump it out, try something different. You probably need some dirty water. Well, I can tell you how to make dirty water. That's the experiment. I hope you would have fun doing this yourself, making a filter yourself, filtering the material. There are a lot of resources online about do-it-yourself homemade household filters using water bottles and various materials that you can put into it to act as filters. Remember, this is only making the water cleaner. It's not making the water pure. It's not safe. Do not drink this water. Do not drink it after it comes through any filter. Okay? Whenever you're doing something like this, you want to be a little bit careful. I know these are household chemicals, but the safest thing would be if you had some kind of eye protection and maybe if you wore rubber gloves. That's the experiment. You see, it's a nice, colorful experiment. It's a lot of fun. I hope you have fun doing it. Thanks for watching.